Morning, new topic, vectors. So if you want to write that heading down, we'll have a quick look at the starter.
Hey. I'm applying for a new film loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranodon! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. You want a demonstration? Oh, ow! It's so difficult sometimes to keep the line outside.
So now some notes. Definitions. As Vector just said, the vector has both magnitude and direction. And we can use a directed line segment. So a line with an arrow in it, exactly as Vector just said. So the vector PQ starts at P, finishes at Q. There you go, that's your vector PQ. A line with an arrow. The vector QP, as you can imagine, starts at Q, finishes at P. There we go, that's Q to P. And we can also use small letters, lowercase letters, to represent vectors, like such, A. Okay, good. So if PQ is equal to RS, then the line segments PQ and RS are equal in length, and they are parallel to each other. So this definition is very important. If PQ equals RS, then their length are the same and they have to be parallel. So if AB is equal to minus BA, then the line segments are equal in length, parallel, but they're running in opposite directions. So that's AB, and that's BA, minus BA is running in the wrong direction. We got positive A and negative A running in the opposite direction. You can add two vectors together using the triangle law for vector addition. Remember, when at any time you want to stop and make notes, click pause. When you're ready, click play again. So we've got the vector addition, AB plus BC equals AC. So that's A to B, AB, and then BC from such. So if I'm going AC, that's the same thing as going from A to B and then B to C. So AC is going to be equal to A add B. So we've got C there is equal to A add B. Okay. Example. So I want you to make notes of that and draw a parallelogram. We'll have a look at this parallelogram OACB. P, Q, M, and N are midpoints of the sides. O to A, OA is equal to A, and OB is equal to B. Because they're parallelogram, that means that AC is also equal to B, because it's the same size and parallel, and BC is equal to A, same length and running parallel to OA. So we've got to write the following in terms of A and B. So first I've got to do OC. So to get to OC, I can go OA plus AC. So I can go A plus AC, I know is B, so that'll be A add B. Let's go AB. So AB, I can go across AC and then down CB. So AC is going to be B, and then CA is going in the opposite direction, so it's minus A. So it's B minus A. So AB is equal to B minus A. QC. Now AC is B, Q is halfway through, so that's going to be half of B. So QC, there we are, it's half of B. CN is running in the opposite direction to AM, to MA, opposite direction to MA, CN. So that's also going to be half of A, but in the opposite direction, so it'll be minus half of A. And QN, so QN, going across there and across there again. So that's going to be half of B minus half of B minus half of A. And a question for you. What can you deduce about AB and QN? So AB and QN. QN is going that way. So AB and QN. Just by looking at them. Well, we've got AB equals B minus A, and QN equals half of B minus A. We can factorize this. So Qn is equal to half of B minus A. So it's the same vector. AB is equal to B minus A, and Qn is equal to half of B minus A. So that means they're running in the same direction, so they're parallel, but one is half the size of the other. Okay. So they are parallel, and Qn is half the size of AB. Let's have a look at another example. Triangle OAB. M is the midpoint of OA, so it's halfway between those, and N divides AB in the ratio of 1 to 2. So that's your M, that's your N. So that's 1, and that's 2 parts there. OM is equal to A, and OB is equal to B. So all of that length there is equal to B. Okay, express ON, so we've got to go across there and down there, in terms of A and B. Now, I know OM is A, and I know that that's M is a midpoint, so that means MA, the same size, traveling in the same direction. That's also going to be equal to A. So that's A and that's A. Now ON is going to be equal to OA plus AN. It's going across there and down there. But I have no idea in terms of A and B what AB is. So I can work that out. N divides AB in ratio of 1 to 2, so that means this is 1, AN is 1, NB is 2, so it's a total of 3. So this is a third of the length of AB, and this is 2/3 the length of AB. So if I work out what AB is, there we are, AN is a third of AB. So if we work out AB, then we can work out what a third of AB is. AB is given by going down here, AO minus 2A plus B. So minus 2A plus B, minus 2A plus B. Minus 2A plus B, or B minus 2A, either way around is fine. And AN is going to be a third of that, so if we divide AB by 3, so it's minus 2 over 3A plus 1 over 3B. That's my AN. So OA is 2A plus that. So if I work that out, 2A plus minus 2/3 of A plus 1/3 of B. I can simplify 2A minus 2/3 of A. That gives me 4 over 3A plus 1/3 of B. So if you make some notes. Your questions are exercise 11A, page 234 to 235, so 11 questions. Off you go, good luck.